All right, welcome back. This is Computer Science E75. This is lecture 4, where we will finally introduce an actual discussion of databases, namely MySQL and a language called SQL. But first, just a couple of comments on what to expect now that you've actually started diving into actual projects. We grade these projects fairly coarsely, trying to focus more on qualitative feedback than quantitative. And by that I mean we pretty much evaluate each project along 3 axes. So you'll get back 3 numbers or qualitative labels. From poor on up to best. At the beginning of the semester, it is absolutely to be expected and to be a good thing if you're in that 3 range, the good range. Good does mean good, even though 3 is, if you do 3 divided by 5, you get 60%, which in most contexts is a D or whatever. That is not the case here. 3 means good, and good is in fact good. It is not a 60%. So what we generally look for in projects throughout the semester, even though there are only a handful of them, is starting off the term with some 3s, maybe even a 2 or so here along some axis, but then working your way upward toward 4s and 5s. We tend to give more weight ultimately to correctness because at the end of the day, this notion of correctness is probably the one you spend the most amount of time chasing down bugs, getting things to work. Whereas design and style are a little more subjective in nature. So a quick word on what we mean by these. So correctness is what the word implies. Does your project work as it's supposed to? Did you correctly check off all of the boxes on the specification and implement all of the required features? Or are there ways we can break your code? Even though, for instance, we might not explicitly say in the spec, if we type in a negative number, your program should not crash or your website should not crash. Well, that should go without saying, frankly. When it comes to implementing the project, you should absolutely assume an adversarial user or an adversarial teaching fellow who is trying to find fault in one site. Frankly, too little of this kind of testing is done in the real world, and this is why websites are all too frequently compromised and accounts are cracked into. And so it's a very good habit to get into, always expecting the user to do something you weren't expecting and to code defensively. So what does this mean? Absolutely, anytime you're taking input from the user, you should not assume that just because you said input a quantity here, that they're actually going to input a quantity as opposed to their name or something like 0 or -1. So we're certainly going to think about what case might this developer, this student not have thought of, and we're going to try typing that in ourselves, and odds are a if condition here, an else condition here can catch almost all of these things. And we'll talk before long about more serious threats, things called SQL injections attacks, cross-site scripting attacks, things that are a little more sophisticated than just inputting negative numbers where positive numbers are expected. So we'll run the gamut of defensive coding for the simplest of scenarios and also more complex attacks. So do keep that in mind. What does design mean? So design means does your particular implementation manifest thought? Does it use good coding practices? The course does, of course, assume prior programming experience. And so if you're finding yourself copying and pasting the same kind of code again and again and again, that would probably violate this tenet of good design, whereby you should probably have factored that code out into a function, for instance, or into a separate file. We'll discuss in sections and also in lectures various approaches you can take to implementing larger projects, for instance. For instance, a design methodology you might have seen with the teaching fellows already is that if you want to have a common header on every page, the same, for instance, title and the same menu bar, and a common footer on every page, which is pretty much the norm these days on the internet, you probably should not be having an index.php and a foo.php and a bar.php, all of which are copies of one another that you've just made, and then you're tweaking the middle of those files, essentially. You can implement this in a number of ways, but perhaps the simplest would be to take this approach. You can absolutely have index.php representing your home page, the main menu, for instance, for the pizzeria. You can absolutely have, let's call it, not foo, but something more specific, order.php, which is maybe the confirmation screen or something like that, and a couple of other files. But if you're going to have some common content to each of these files, odds are you want to take one of a few approaches. You could have a file called header.php and footer.php, which contains only that HTML and maybe PHP content that you want to get executed on every one of your pages. And then via what mechanism or function call that we've seen can I include each of these files in each of these? So there's an include function and there's another one, require, and there's actually 4 of these variants thereof total. I think in the code I've written almost always use require. Require, given an argument, takes the name of a file that you want to require that exist and be copied and pasted here, essentially. So a top index.php, you might start this by saying require, quote unquote, header.php. And what will happen, because you've said require, is that if this file does not exist, the the interpretation of this page will halt immediately. You will get a PHP error, and the user will see nothing. Or if you have errors being displayed, they will see whatever error message is appropriate for this scenario. So require is actually a better statement generally than include. Include is a best effort. If the file's here, please include it, which generally is not what you want. Odds are, if you want to include something, you want to include something. So in PHP, a better habit to get into is require. There are other variants that you'll sometimes see. There's require once, and I think include once, which is just a mechanism whereby just in case this file's including this one and this one's including this one, you can make sure that a certain file like config.php is only included once. It's only pasted once, and if you see require once multiple times, all subsequent invocations are ignored. As an aside, using require once and even include once tend to incur a bit of a performance penalty because PHP has to keep track of whether or not it's required that file before. But for most sites, this is probably pretty negligible, certainly on today's hardware. So just to be clear, if you start off index.php with a line of code like this, you can then end index.php with a line of code like this, require footer.php. And then inside this file, can you put only that content that is germane to the main page of your website? Now, there's some other approaches here, too. So a couple of refinements I would propose. Odds are you don't want users on the internet visiting footer.php directly in their browser by visiting this URL. And you probably don't want them visiting header.php directly, if only because it just makes no sense. They'll get a partial page. And also, it feels like if they're not meant to see those files, they shouldn't be able to, even by guessing what those file names are. So per our conversation last week, we proposed, when we created your accounts, that you put such files where? So anywhere else other than HTML was really the takeaway. And you can name the directory anything you want, but if you want to use the scheme we've proposed initially, instead I would write something like require quote unquote /lib /header.php or wherever you put it. But the point being to put it outside of the HTML directory hierarchy so that a user, even if they know or guess that a file like this exists, the web server will prevent them from actually accessing it. Now, there's a couple of other things to point out here. This feels like it's getting a little redundant, requiring the same files again and again, and I feel like I might want to call a function, for instance, that does this. So you can absolutely implement a function called header, or actually don't call it header because that already exists, but you might have a function that's called print header. So let me just do this with a text editor rather than using chalk for what is ostensibly code. If I might want to do something like this, print header. And I could just have a function, frankly, just in the interests of kind of abstracting away the notion of printing the header and printing the footer. I could simply do something like this, require .. /lib /header.php. And now even though this feels like a useless exercise because I've just moved one line of code elsewhere, and in fact now I've got 3 lines of code, whereas previously I just had 1, in theory, as your projects get more sophisticated, you could start to do more interesting things. You could pass arguments to the print headers function that would allow you to parameterize the behavior. For instance, if you wanted the title of your page to differ based on what page they're on, you could do something like this, title, and now let me ... Suppose this is the contents of header.php, just to give you a taste of this. If this is HTML, this is head, what I could do is something like this, title, and then I could dynamically include that variable that had been passed in, ... So if you abstract away the notion of printing the header of your page, put it in a function that itself might take arguments, you can then start to do some more dynamic things so that every page doesn't literally need to be the same. It can vary slightly even up top. So this would be one approach. But frankly, it's a wonderfully useful place to start. Even the course's website, we have this 3-column format. That isn't uncommon these days, certainly with websites. Sometimes you see 2 columns or 1 column. But essentially, because of the way we've structured this, and we are actually using tables invisibly underneath the hood for fluidity's sake, so it grows to fill the window, this The left column and everything up top is essentially in a file called header.php. Everything in the right column is in footer.php, and all we do in each of our directories for lectures, for sections, for resources and all of that, we just put the HTML markup unique to that page in the middle there. So it's a common approach, and it's a nice way to start because it's fairly straightforward, certainly for a site that has a few pages, all of which follow some common theme. So any questions? Yeah?
If you want to build an object-oriented application, include lots of files, do you recommend using like auto group or?
So good question. So we in the course won't focus too much on OOP type methodologies, even though PHP 5 and onward does support it, just so that we're not assuming that background as well, and because the reality is most PHP code out there is still rather procedural in nature. But yes, you could absolutely do that, and PHP actually has some really neat, sophisticated tricks whereby if you can define let's see, what's the best example here? So short answer, yes, you are welcome to use other features of PHP, like the auto-loading that we might not discuss. I'm trying to think the best way to describe this. So the simple XML API that we started using last week, it allows you to use the bracket notation to get at attributes, and it allows you to use the arrow notation to get at child elements. It's actually doing this thanks to really neat tricks that PHP provides. Simple XML is the name of a class, it turns out, in PHP. And any class in PHP can have certain special functions defined inside of it. One is called __get. And that get function, if you implement it, will be called automatically if you try to access a property of an object that doesn't actually exist. So you can intercept all calls into an object using this arrow notation or even the square bracket notation, and then implement that notion of getting a property or function in any way you see fit. So in Spirit, those of you with C++ backgrounds, this is kind of similar to operator overloading, but implemented in a different way. And so just as a teaser, especially if you are coming to the course with more comfort and more programming experience, realize that there are some neat features that you can dive into that we'll get to maybe toward the end of the course, but not necessarily up front. So, in fact, why don't we then... Oh, and actually, just to round out this one discussion here. So design, to summarize, means just how well designed is it? Are things fairly modularized? Do we see a lot of copy-paste, which probably suggests that things could be better designed? Are you, for instance, using, the easy things like, are you looping instead of copying and pasting your code 3 different times? So in general, this is something that's fairly subjective. It's not like we can offer some definitive rules to follow, but this is what we use sections for, and also as the projects proceed in the semester to provide feedback with, so as to get better at this notion. Style, frankly, is probably the easiest of any of them. Style means purely the aesthetics, the human readability aspects. Are you choosing useful variable names and not just XYZ and X2, X3, X4, and so forth? Is your code reasonably commented? One thing we don't expect for the course is that generally in programming, most people like to adhere to a rule of like 76 characters or 80 characters maximally per line. After that, you should be hitting enter and indenting appropriately. Frankly, I think that tends to make web-oriented code less readable, especially since most of us probably are not printing out our code anymore, and so you don't really need to confine yourself to a 8.5 by 11 sheet of paper in Spirit. And so personally, I think it's perfectly fine to let your code wrap, and I think, frankly, HTML tends to be more readable if you just let it wrap left to right and then flow even onto a second line. But the point that we look for ultimately with respect to style is just be self-consistent. Whatever habits you're coming to the course with, so then as long as they're not crazy, continue to practice those same habits, but be consistent within your own code. And we're not going to expect any sort of official style for the course. Any questions on such? Yeah? No. You can choose the ugliest colors. You can use the ugliest font. We don't care. The course focuses more on programming, the implementation ideas. Design, for instance, is not my forte, so who would I be to judge the design of others' sites? And I also think it's incidental to the course, certainly. It's not meant to be an aesthetic design course. We're much more interested in the ideas, the computer science, the data structures and algorithms underneath the implementations of these projects. If design is not your forte either, then you're in the right place. And if it is, don't mean to offend. With that said, to be clear, validity of code, like well-formedness of HTML or XHTML, depending on which variant you use, that's to be expected. Things that we can evaluate objectively, things that are consistent with best practices is good. But if you really like certain color of brown that we would not choose ourselves, not a problem. All right. Okay, so this was this last slide we looked at last time, and frankly, it looks a little unnecessarily intimidating, but it captures sort of all the basic definitions in this language called XML path or XPath. This is a query language, and we'll see a more popular one today, SQL, one that's a little more expressive, but this is incredibly handy. Thus far, if you've dived into Project 1, you've probably been using the arrow notation or the bracket notation to access members of your XML file, if you've crafted menu.xml. But probably in your project, you will get to the point of rendering an order page for this pizzeria. The user is going to add something to their shopping cart by clicking a link or maybe clicking a submit button or something like that. And then probably you're going to be storing that information in what superglobal to remember that the user has added something to their shopping cart. So $_session, right? That's this magical associative array that you can trust will have whatever variables you put in it a few minutes ago, so long as you're calling session start atop every one of your pages. Now, and as an aside, this kind of design approach where you're including the same header file in every one of your pages is a perfect candidate for including inside of header.php that one call to session start. So in one fell swoop, you ensure that it's always called. You don't need to manually do it. So suppose that what you're really storing in the shopping cart is some unique key of an item on the menu, or if that feels a little too fancy for the pizzeria's owners, well, maybe you just store the name of the item in the shopping cart. So long as it's unique, that too could suffice as a key, a reliable lookup mechanism. Now, you could store the price of the item in the session object along with the quantity that the user has chosen and the name or an ID of it. That doesn't feel very efficient because it feels like you now have data in multiple places, but it's arguably okay, especially for sort of a low-tech implementation of this website anyway, because you are, again, just relying on text files, no fancy databases or anything. But suppose that you were just storing the keys, which feels cleaner. Just store the minimal amount of information that you need, and then just get dynamically information like the prices when it comes time to check the user out, or to confirm that the item they've chosen comes in medium or comes in large or something like that. So that begs the question, if I know that the item has an ID of 123, or I know that the item has a name of mushroom pizza, how can I find that element inside the XML file with that same ID or with that same name? In other words, how do you look things up in the XML file? Well, last week we saw how you could iterate over that arbitrary file called lectures.xml, which represented all of our lectures. So we saw how you could very easily iterate over all of the lecture elements in a file, all of the resource elements in a file, all of the format elements in the file. So frankly, you could just do an exhaustive search. You could iterate over all of your item elements or food elements, whatever you're calling them, in menu.xml, and just check, is the name of this one equal to mushroom pizza? Or is the ID of this one equal to 123? If not, just let the loop keep going, and as soon as you find it, you can use the break statement in PHP, common to a lot of languages, and voila. Now you have the element in a variable that you care about. This doesn't feel very efficient, especially if the file is large. It feels like it'd be nice if I know in advance I just want the mushroom pizza element, or I want the element with ID 123. Let me just grab it and get at it directly. XPath allows you to do that. So this syntax here is a little more verbose than you generally need, but let me propose this. So on the fly here, this is not necessarily how you should implement your own menu, and I'll do an abridged version of it, but suppose I call my menu root element menu, and suppose I have something like an item here. And again, I'm doing this on the fly. There is no one way to do this, so please don't let us see 80 implementations of this menu in particular. Name, this will be called mushroom pizza. And you know what, just to make my life easier, I'm going to go ahead and teach the pizzeria guy, you know what, you got to give every item in your file a unique ID. So let's just call this mushroom pizza. And I'll just have to teach him that you need to come up with some convention like that. It's not necessary. So long as I keep the names unique, I could do that instead. But I'll just do this so that I have an attribute to play with and a child element to play with. So now I've got a whole bunch of other items in my menu. And notice I'm disregarding the the ideas of medium and small and toppings and all of that. I'm keeping it simple for this purpose. Let me go ahead and just come up with some other examples. Cheese pizza. We'll call this cheese pizza. I mean, already these IDs seem kind of stupid. If they're so close to the name, might as well use the name itself, but so be it for now. Let me go ahead and... Actually, you know what? Let's just tell the guy, go ahead and make it... well, even that's technicality. Let's... do I want to do that? No, let's do this. So I'm hesitating because XML has this stupid limitation where an ID attribute, an attribute of type ID, can actually not start with a number, which is a really annoying headache. So I'm trying not to mislead in that way. Frankly, if we don't use what's called a DTD or an XML schema, doesn't matter. I can violate that constraint all I want, but just to be consistent, I'll use alphabetical only for now. All right, and this one, let's call this pepperoni pizza and pepperoni pizza. Okay, so now I have a menu. It's got 3 items on it. In it, I can certainly iterate over each of these item elements by doing something like this. So now let's change contexts, and let's pretend we're back in PHP mode from last week. I might do this simple XML load file. I can load menu.xml, and then I can iterate over each of these elements. Recall by doing something like this. For each DOM item as item, I can just do something like if item ID equals mushroom pizza, then go ahead and do something. Now, of course, I probably wouldn't be hard coding into my program the key mushroom pizza. Odds are this string here is stored in a variable that starts with a $sign. But the point here is that I could absolutely find the mushroom pizza pretty easily just by exhaustively searching the file. Can I do better? Can I dive in and just grab the only element I care about? Well, you can using this language called XML path. So a path, much like should conjure up the notion of like a file system path, C:\/ whatever. So in fact, that's what happens here. So on the left-hand side, you start at the root of the document. So / represents the root of your XML DOM, the root element specifically. Now, child : is what's called an axis. It says from that point, what kinds of nodes do you want to proceed to explore? So child, in fact, is going to be the default, as we'll see. But I'm being very explicit here, and I'm saying use the child axis, and then grab me the lectures element. So this is consistent with our example from last week, where we had lectures.xml. Root element was lectures, inside of which was one or more lecture elements. And in those was resources and formats and all of that. So what I'm next doing here is taking another step. So together an axis and what's generally called a node test, or in this case just the name of a node, lectures, I'm taking another step as suggested by the /, again along the child axis, but for this next level of the tree. So step is actually a pretty good word here to use. I'm starting at the root and I'm stepping into the pool of children here, looking for the ones called lectures. Presumably there's just one since I started at the root. My next step is going to be to dive into the layer of the tree that has lecture descendants. And then from there, I say, wait a minute, don't get me all of the lecture elements. Recall that we said briefly last week that the bracket notation denotes a predicate, and a predicate is a filter. It's a Boolean test that says yes or no, include the following nodes. So this test here, as the @ sign suggests, says check for the attribute, attribute, called number, and if it equals 0, it is a single equal sign. It's not equals an XPath. If it equals 0, then go ahead and include it in the so-called result set. So XPath is all about getting a result set, a whole bunch of nodes together, and you get them back as a PHP array. So what does this do for us then? Well, I am essentially grabbing with this path here all of the lecture elements in the DOM whose number attribute is 0. Now, odds are, by construction of this document, if you recall, I'm just going to get back an array with one element in it, and that's fine, but it will, in fact, be an array. So the syntax with which I can do this in PHP is a little something like this. Instead of this loop, I can instead do this. Results gets DOM. DOM supports an XPath function. So a simple XML element supports a function called XPath, and it takes XPath query. It takes a location path, as is the jargon. That whole thing is a location path. So I could do this, and I'm going to simplify. So if you're scribbling this down, you don't necessarily want to write down this first version. Child : menu slash child colon item predicate, so square brackets, ID equals give me mushroom pizza, single quote, close quote. So it's wrapping onto 2 lines, but shrink it down a little bit. And let me move it to the top. That is the way in PHP whereby I can call this XPath function, I can specify a location path, and get back specifically only those nodes that manifest a certain property. In this case, the number attribute being 0. So odds are I'll get back an array of size 1. And if I index into that array at location bracket 0 bracket, as you would in most languages, I will have, in fact, the lecture element that I actually care about. And I didn't have to loop over the entirety of it. Now, the compelling features here are, one, rest assured we can simplify the syntax because it looks atrocious and it doesn't look like a very nice language to interact with. But we can clean that up in just a moment. But 2, if the simple XML API is being smart, it's going to load this XML file, however big it is, into a pretty sophisticated data structure in memory, some tree-like structure. And if it's smart, it's going to do some kind of hashing. It's going to remember which nodes are where, so that when we actually perform this query, it's not going to do the naive approach of iterating over every possible node, checking all of these nodes. It's going to use some fancy lookup table that it conjured up. Now, whether or not simple XML does that, I'm not sure. I've not looked at its own source code, but this is the opportunity that the XPath language presents. Now, PHP has its own implementation of this function, but it's particularly well supported in Java, as well as in C++, and other languages these days. And what's nice is that, as the notion of a path suggests, child is in fact the default access. So we don't need the stupidity of an explicit mention of the access. We can really just, let me finish the function call here. We can really just say what we mean. /foo/bar, predicate here and there, and just assume child access along the way. In fact, I already took a shortcut. That @ sign is actually shorthand notation for attribute, the attribute access, which really looks like this. But no one would use this language if you had to type out this kind of verboseness all of the time. So the @ sign is the shorthand notation, just as the empty string is the shorthand notation for child : Yeah? It is. If you want mushroom pizza to be a variable, you can absolutely just do, let's call it var for now. This would work, but what's important in this context is that I'm using double quotes on the outside of the whole argument, because recall from last week that in PHP, double quotes mean any $ variables inside should be interpolated. So it's important that I make sure the outermost quotes are in fact double. Otherwise, it will literally search for $var in the file, which is probably not going to be present. So at this point, once I have that, I can do something like if count results equals 1 or just greater than 0, something like that. I can then grab this element, and let's call this item gets results bracket 0, for instance. And at this point in the story, I can now do something with that particular item because I've plucked it out of the DOM. Now, we're really just scratching the surface. As an aside, there's many different axes supported by XPath. There's a parent access. There's a predecessor access. Predecessor. Is that? I think it's called predecessor. No, maybe, yes, I think so. There's an ancestor access, descendant access. In fact, one that's a little handy for small files, though I would not get in the habit of doing this. If you're not sure where in the DOM a certain node might be found, that is, you're not sure how deep it's found, you can actually be a bit lazy and just use // Technically, the // access is shorthand notation for descendant or self. ::star. So again, the people who came up with this really were explicit as possible, but thankfully we have shorthand notation for the most common ones. // means find the any item elements in the DOM at any level, wherever they are, so long as they match that predicate. The downside here of using the shorthand notation, that while it might be useful for doing quick and dirty tests looking for things, while it might be reasonable to do for fairly small files, you are now undoing the efficiencies offered by the whole DOM, because // means search the whole darn DOM looking for item elements everywhere, and that's just dumb. If you're the author of that XML file, you know where those elements should be. My God, tell the computer where you put them so as to save unnecessary work and avoid wasting cycles. So it's actually really cool. And frankly, the fact that XPath is increasingly well supported in any tools that support XML really make it a compelling markup language to use for configuration files, for even small databases, because you now have a query language. You don't have to search through it. By contrast, CSV files, there really is no API. There's no query language for CSV files. You iterate over that whole file, top to bottom, left to right, if you want to find some value. So this is one advantage over that slightly more naive approach of just text files. Any questions? Okay. All right. So let's see then if we can do better. So we can do differently. So CSV is not a bad file format to use. It's incredibly cross-platform because it is just text. You do have to avoid stupid issues whereby in the world of Linux and Unix, generally, the world decided that in order to represent the end of a file, the end of a line, use \n. Unfortunately, Microsoft decided to use what instead? Right, so \r, \n, and for God knows what reason, Apple decided to use line feed? Not line feed, but generally carriage return, \r. So in the three most popular operating systems, at least these days, you have three different approaches, and there's frankly very little compelling reason. The difference, as an aside, if you remember like sort of old school typewriters where you have to like pull that crank and then the thing rotates and the head moves back this way, well, carriage return means move the typewriter's head all the way back to the left, so you can start typing a new paragraph or whatever, whereas a line feed, N, actually rotates the wheel and moves you on to the next line. So conceptually, Windows isn't a bad translation of the mechanical world to the virtual. It's not this doesn't often offer you, it's very rare that you care about distinguishing the idea of moving the cursor to the beginning of the line versus on to the next line, though you can contrive scenarios where that's useful. But the fact that all three of them just do it differently is annoying. And I mention this only because when you're actually sharing data with someone else, it's these stupid kinds of issues that can sometimes get in the way. So being mindful of this is a good thing, especially in the context of CSVs. Sometimes what should be conceptually rows and columns ends up just being one huge row, and that's just because your operating system or your language doesn't realize what the line terminator should be. And the solution to this varies. It's always something simple and Googleable, but just let me plant that seed as something to be mindful of when you're relying on text files only. Same deal with XML as well, if it proves relevant, but most XML parsers should be resilient to this problem. So PHP works out of the box with CSV files really well. And this is a really nice feature because as simple as CSV files are, for those familiar, CSV is comma. Okay, so everyone's familiar. So comma separated values. This is just sort of a poor man's way of implementing an Excel file just using a text file, not using any kind of proprietary format. The comma just denotes that if you want to have a column like X, Y, X's and Y's and Z's, and then you have another row, or cell, another row, and so forth. Well, you just conceptually, what are these bars in your file really just get implemented as commas in the file, and then you put something like \n to demark the end of the row, and you proceed on your way. The world also likes TSVs for tab-separated values, where you use \t. The world likes PSVs, which is the vertical bar separated values. I don't know why some people choose one or the other. With the right tools, it shouldn't matter. Because even if you can, in fact, include commas in comma-separated value files, and same for tabs and pipes, but it is actually quite useful to use tools for this. So the immediate gotcha with a CSV file is what if you want to put not just X or Y or Z in a column, what if you want to put Cambridge, Massachusetts as a value in one of these columns? That comma would seem to confuse whatever program is reading this so that that row with Cambridge, Mass actually has an extra column in it because of the additional comma. Well, thankfully, the world came up with a solution for this too. What would you do if you were the programmer? Oh, sorry? I heard a couple of thoughts. So you can put quotes around it. What else might you do? You can escape it somehow, maybe with a \. A couple of different approaches, but in CSV, the convention does tend to be you simply put that whole field in quotes so that the next quote would go there, the previous one would go there, and yes, there is this worrisome thing, but because the whole field is surrounded by double quotes or single quotes, hopefully is not a problem. So I mention this now because one of the nice things about having this built into the language is you don't have to think about this kind of stupidity. If you want to read a file or write a file, you can let someone else's hard work, who's thought about all these annoying corner cases, do the job for you. And two of PHP's most useful functions, to be honest, in that they do all of this for you, is fgetCSV. And as the name implies, this gets from a file, a CSV file, and here's its snippet of its documentation. Generally, a good approach when reading the docs is you can certainly start at the top, but frankly, I tend to get impatient, and I just want to see and learn from an example. So here, for instance, is an example on php.net. What you can do first is you call fopen, and you pass in the name of the file. You specify, quote unquote, you want to open the file in read mode, which is a common feature of this fopen function in multiple languages. You can then check, is the return value false? We're seeing, I think for the first time in examples, this equal notation. So long story short, and we'll see this again, PHP is very loosely typed. There is the notion of floating point values and integers and strings. There are different data types, but we've never seen us have to specify, do we want an int in that variable, a string, a char, or whatever. PHP is loosely typed in that you don't have to think about that. But there is, in fact, this operator, bang equals equals, which is the not equal operator. But it's a little more than that. When you use double equal signs, what PHP does is it checks that not only are the value what you're comparing, but also are the types actually the same. So in this case, this is probably just being a bit pedantic here, because fopen should not really return the value of 0. But what this is being used for in general is if a function might return an int, 0, but it could also return false to indicate errors, by using bang equals equals, you can distinguish 0 from false. So it's actually quite useful. Now this is both sort of this is kind of a two-edged sword in PHP. PHP functions can return different types. One function can return a string, an int, a char, false, true, anything it actually wants. And this is minorly annoying, but it's also kind of useful because if you think back to a lot of languages like Java and C, if you have to pick a data type like an int, but sometimes errors happen, and it's really hard to signal that error unless you use exceptions, which at least C does not even have, or you can choose some sentinel value and return -1 arbitrarily to signify an error, but that's kind of a conceptual mismatch. If I'm returning an int, every int should be a valid response. I shouldn't hard code one of them to signify error. So what's actually kind of nice about PHP is that you have sort of this out-of-band way of saying, you're not getting back the data type you expected. Here's a different data type altogether. You can still check the return value. You don't have to jump through hoops with try and catch, constructs common in a lot of languages, but you can distinguish the type thanks to this operator and then just equals if you want to check value and type, and ignore the implicit casting that goes on between 0 and false and 1 and true and so forth. So back to the story with fgetCSV. This is actually more complicated than it needs to be. The most robust way to call fgetCSV, even though it might not be the most efficient, is to call fgetCSV on the return value of fopen, which came from up here, and then you can actually omit this stuff. This is saying read up to 1,000 chars at a time. The problem is if one of your columns is 1,001 characters, you just broke your code. Frankly, I've never once included this because that's just kind of an unnecessary risk, I think. Better to just let the memory management happen for you. So you can generally just close your paren there, and this will read in the next line of text from a CSV file. It will figure out where all of the commas are, and it will then hand you a numerically indexed array where each location in that array represents one of the columns. And it does all of the escaping for you. fputCSV, by contrast, does the opposite. If you want to write out some CSV data, it will do all of the escaping for you, commas, quotes, and all of that. And in fact, even though this is called CSV, if we look at the signature of the function, you can actually specify a different delimiter. The default is comma, but you can put in \t, you can put a pipe in there, you can put whatever you want. It's wonderfully handy having the kitchen sink in PHP. Whew. Any questions? All right, so who cares about CSV, right? Feels like we should be looking at more sophisticated things. Frankly, sometimes that is the most compelling way to store some data. Frankly, sometimes that is the way you need to import some data. For instance, what you will see later in the semester is we will likely use Yahoo Finance to get nearly real-time stock quotes. Yahoo makes these available in downloadable format for people with Microsoft Excel, but it turns out they're not generating .xls files, they're outputting .csv files. And what's nice is with PHP, just as we can use simple XML load file and load a URL, which we did last week, you can also pass a URL to fopen in PHP, so long as the feature is enabled, and it will just go get that URL for you and hand it back to you. You can pass it to fgetCSV, parse it as usual. So we'll be able to use this mechanism, this one-liner essentially, to parse nearly real-time stock quote data from Yahoo Finance, simply because they distribute their data in CSV. Now, as an aside, it's been this way for like 5 years now. Yahoo CSV feeds are broken. You can request certain fields that have, guess what, in them? Commas that they do not actually escape for some reason. This has never been brought to the appropriate person's attention. It's been broken for 5 years, so the solution, don't request those fields. It's fields like description or something that by nature might have commas in it. They just don't put quotes around those fields. So even the big fish sometimes get these things wrong. So then we looked last week at XML, and this is what you're using or will be using for Project 1 to actually represent your menu. What are some of the upsides are you sensing to XML thus far? Vis-a-vis CSV or anything else that comes to mind? So it's readable by humans. It's searchable, now we know, from XPath. It's hierarchical. So you get some notion of hierarchy, indentation. You can represent objects conceptually with XML that you can't really with CSV, at least not as easily, where everything is a flat row, which doesn't lend itself to relationships, or you don't have attributes and these kinds of meta details. Other things? Yeah?
You can always describe more about each of the elements.
You can describe more, and you can keep things semantically distinguished by adding, for instance, the middle name or the last name tags that we looked at with some sample XML fragments. So you just kind of get all that you get with CSV plus more, right? It's still a text file. You can still create that database. The pizzeria can create that database with notepad.exe. So you don't really need special tools or savvy, even though you have to know a little bit about well-formedness, and it is easier to break, but you get a lot more features. Now, besides making it easy to break, and I'll testify that even I have updated the course's website from time to time and accidentally copied and pasted too few lines of XML, so my code is no longer well-formed. And then we get an email from a student saying, why is the lectures page all blank? And that's because the XML can't be parsed anymore. So that's one downside. It's more sensitive, perhaps, than something like CSV, where you can see the rows in your Excel file or whatever. What else might be a downside of it? Yeah? So it's a bigger file. You got a whole lot of redundancy. You're going to say item, 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 item again and again, whereas those kinds of semantics are implicit in a CSV, for instance, by just what column some piece of data is in. You put it in the header role, and that's it. Other downsides? Anything come to mind? Yep.
No, it's hard to do protection.
It's hard to what?
Hard to protect it. I mean, you don't have user access controls on the text file.
So that's true. So we don't have any of the access controls that we're about to give ourselves in the context of SQL and MySQL specifically, where we'll have more notions of users and authentication. We'll have constraints that we can impose on our data, whereby you cannot insert a row into a SQL database if you violate some constraint. We don't really have any kind of sanity checks in XML or CSV, unless with XML, if we veer off the path of this course and actually use something like DTD and XML schema, which we won't get into, but we could use mechanisms like those. So in short, there's a lot of pluses, to be honest. And frankly, it's incredibly useful, and you get, with the right language, it's as easy, dare say, to navigate as it would be a CSV file. So tuck it away after this project, if nothing else, as a potential tool in your toolkit. But today we focus on SQL, structured query language, which has been around for many years now, is very well supported across all sorts of database engines. We happen to use MySQL in the course, largely because it's 100% free, it's very high performing, and it's incredibly popular these days. Certainly in the world of web programming, can you find most any web host out there supporting MySQL databases? PostgreSQL is another option. In the commercial world, there's Oracle, of course, which supports essentially the same syntax we'll be looking at. There's Microsoft Access, there's SQL Server, there's a whole bunch of variants of it, but for the most part, we'll focus in the course on the features of SQL itself and not as much on MySQL specific features, so that the ideas are very much portable if you're stuck using some other database or you choose to use some other database at work or for some project. What's nice, though, is we'll see there are sort of poor men's implementations of SQL databases, if you will, whereby if you don't have the know-how or the time or the interest or the memory in terms of RAM and disk space to set up something like an actual database server, you can actually still use the very expressive capabilities of this language called SQL but store all of your data in just a file. Not a text file, it'll be a binary file in this case. There's a little more interesting stuff inside of it, but it's incredibly useful if you want to be able to use SQL, which some of you might come to love or hate over the next couple of weeks if you don't know it already, but you don't need the overhead of actually running or knowing how to run an actual database server. And if you're on a shared system, you might not be able to actually install your own database server, but you can create a file. And so long as this database that you're going to implement in a file isn't crazy large, it might be reasonable to let that file be read every time someone visits a page, because it really will give you even more capabilities than XML and certainly CSV. So that's something called SQLite. PHP also supports this out of the box. And what's nice too, with PHP, as with a lot of languages like Java, the world has come up with a lot of libraries, abstraction libraries, JDBC, ODBC, these kinds of acronyms, if you've heard them before, whereby you program against a database using sort of an abstract set of functions, and you don't have to care or know that it's actually MySQL or it's actually SQL Server and the like. So PHP supports something called PDO, Portable Data Objects, which allows you to do exactly this. But for simplicity, for the next project and for the next couple of lectures, we will focus on PHP's native support for MySQL, because they really do enjoy a nice marriage between the two. There's a lot of MySQL-specific functions in PHP that are relatively easy to use, but realize before long, and certainly for your final project, you can veer off in another direction if you prefer some other database engine. Any questions? All right, feels like a good time for a 5-minute break, and then we'll resume by taking a look at our first database server. All right, so where are we going with this? Well, Project 1 will remain pretty much entirely XML-focused, XPath-focused, and PHP-focused. But with Project 2, we'll introduce MySQL itself. And you will also receive accounts on the cloud's MySQL server, with which you can create your own databases. And as we'll see, use a nice graphical web-based GUI with which to create and explore databases and tables that you've created. So that's going to be a tool called PHP MyAdmin, but more on that in just a moment. So what is a relational database? So a relational database is pretty much a database implemented via one or more tables. What's a table? Well, frankly, Microsoft Excel offers a pretty decent visualization of this. A table is something with rows and columns. Generally, each of those columns means something. You might have the left column be someone's ID, the next column their first name, the next column their last name, and so forth. And then every row in a table represents, in that scenario, a specific user. So in that sense, it's not unlike CSV files at all. It's very, in fact, similar to that. But what's nice about relational databases, as opposed to just CSV files, is that you can have multiple tables in memory. You can have access to multiple tables, much like you can CSV files, but you can perform some standard query on a relational database using a language like SQL that you simply don't have the capabilities of in CSV, where you have to just know yourself from design what each of the columns means. So now can we actually start searching data? We can insert data. We can delete data. We can sort data. We can do what's called joining data. You get a lot of expressive capabilities in SQL. So MySQL happens to be one implementation of a relational database that supports SQL. It, again, is quite popular, it's quite free, it's quite high performing, and it's pretty easy to get up and running with, especially thanks to some of the tools that it supports. So back in the day, you would interface with it via command line environment. You would run a command called MySQL, and you would find yourself at a MySQL prompt, and you could then type your commands here. You could create your tables at this interface, and you can do that ultimately on the cloud, and you're welcome to do so if you're a fan of the command line. But frankly, it introduces some unnecessary hurdles, and it's just not that much fun to use, and so we'll generally promote, and this is something, frankly, I use most every day, a tool called PHP MyAdmin. It's actually a coincidence that the tool itself is written in PHP. We use it not because of that, but because it's so wonderfully useful. But it's nice for two reasons. One, it just lets you, with a GUI interface, create databases, create tables, see what data is in your tables. It allows you to insert data, delete data. It pretty much allows you to interact with your MySQL tables as though it were just an Excel spreadsheet with multiple worksheets inside of it. But you can execute queries manually. You can learn to from the interface, which is its second most compelling feature. Pedagogically, PHP MyAdmin is a huge win for just learning the language and learning the ideas, because when in doubt, much like autocomplete in an integrated development environment for a language, you can see with a drop-down, what can I do at this point in the story? What commands are available? What data types are available? So frankly, in terms of learning this stuff, you're presented at almost every step with the available options supported by SQL and MySQL. So it's just a wonderful learning tool as well. So I'd certainly encourage you to get familiar with this. This happens to be the default screen that you tend to see when it's installed. On a commercial web host, you would generally get an account for MySQL on the cloud. Again, you'll get an email or instructions before Project 1. When Project 2 ships in a couple of weeks' time. So realize you'll have access to this right in your own environment, and it's very easy to get up and running, relatively speaking, on your own machines using XAMPP or XAMPP, whichever it is. Has anyone confirmed? I feel silly always qualifying that I don't know how to pronounce it. XAMPP? Okay, still no. But MySQL, I did call the company called MySQL once, and they do in fact pronounce themselves MySQL, not MySQL, which frankly I find silly. It's a lot faster and fewer syllables to say MySQL, but it's their company. So what can you actually do with this? Well, we'll come back to the GUI in just a moment, because learning the GUI is certainly not an academic exercise, but we'll use it as a learning tool. But let's see what to expect. So with SQL, you have some fairly basic and common commands that you'll use most of the time. And the four of them that you'll use most of the time are these. Select, insert, update, delete, that frankly do what they say. Now we'll see shortly what syntax you use to actually select rows from a table, and how to insert rows into a table, how to change rows in a table, and how to remove rows from a table, but they generally boil down to those statements there. SQL is case insensitive with its commands. A common convention, though, is to capitalize any SQL syntax. This is certainly what I do, and then use lowercase only when needed for things like your table names, your value names, if only because readability-wise, it's a lot easier then to skim and distinguish their syntax, the language's syntax, from your own data. But that, too, is just a convention. You'll also occasionally use these. Frankly, I rarely remember the syntax for the first two. Create, whereby you can create a database or create a table with that syntax. And I rarely remember it because I more often interact with the actual tables rather than creating them up front. And there, too, there's the downside of the GUI. Frankly, I probably never really learned the syntax because I always just click, 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 and don't have to think about it too much. But sometimes knowing it's important if you actually want to write code that creates things dynamically. So on those occasions, I've had to kind of suck it up and remember what the syntax is and read the documentation. It's actually not that hard. Dropping tables easy. It's also pretty dangerous. So try not to type the command drop at any point this semester, because odds are you don't want to drop the whole table. But that does, in fact, delete all of your data very quickly. There are a few others that we'll see over time. But we'll start off with these. These are by far the most common and, frankly, among the most useful. So documentation for MySQL. We'll generally use features that are generalizable to most any implementation of an SQL server. On occasion, we might use a MySQL-specific feature because there are little features or extensions that Microsoft and Oracle and MySQL have actually introduced over time that sometimes you want to leverage, but you want to be careful in general, because if you're writing code for a project or for a company and there is a chance that you'll switch to another database at some point, it'd be really nice if your code didn't break. So when we trip over those issues, I'll try to point out, be careful with this one, but it's pretty rare that we'll use anything that's MySQL specific. But the documentation for MySQL, it's not as readable or user-friendly, I'd say, as PHP's. But you should consult it from time to time if you need a definitive answer to something. A not uncommon question would be, if I declare a type, a field in my table to be an int, how big is an int in MySQL? Like being able to look up something like that so that you know how big this number can actually get before you wrap around and problems arise. Those are the kinds of things you want to do consult the documentation for. So it is here. The most probably common version of MySQL out there these days is 5.0 and 5.1, but realize there are older and newer versions out there, so be mindful of that if ever signing up for a commercial web host. But it's this stuff on the right-hand side that's probably a useful reference at some point, though frankly Google generally finds what you're looking for within the docs. All right, so what does this actually let us do? Well, let's go ahead and explore a couple of the features. So in advance tonight, I went ahead and created an account for myself on CS75's cluster. I created a username called Malin Lecture and a database called Malin Lecture. And my password for now is 12345, so we'll leave that alone for now. But let me go ahead and just show you the steps involved in this. And again, the takeaway here is not how to use phpMyAdmin, but rather how to interact with a SQL database. So let's do this. Malin Lecture, 12345, enter. And here I now am logged into the phpMyAdmin interface. So again, most of this, complete distraction for now. We're not going to touch most of these options. We're going to focus more on the juicy part. But notice here that at top left, it says no tables found in database. That's because I just made this thing. But then there is a hyperlink in blue to Malin_lecture 0. That's the database I created in advance. So you will be able similarly to create databases that are initially empty. I'm going to go ahead and click that database. And now this is the interface that you'll be playing with the most, and where you're actually playing with data and not just the UI itself. So let's see what's going on. Top left, fluffy logo. If you ever get lost, hit home. If you want to exit, click exit. I don't think I've ever clicked any of these other three buttons. But this one is useful if you have multiple databases, which you ultimately will for project 2, project 3, and maybe your final project, so that you can keep related tables together and you don't have to worry about your tables mixing. So you can compartmentalize things pretty nicely, you'll see. So here we go. No tables found in database. So let's actually solve a problem here. Well, what about this problem? A while back, we looked at this scenario here. We want to be able to empower users to log into some website. Previously, we only supported one guy, Jay Harvard, whose password was Crimson, and we had hard-coded that into the file. It's a pretty lame implementation, but it at least allowed us to explore the idea of the session at that time, the notion of conditions, and actually logging a user in. Well, today, we can finally start to do better. We can instead rip out those constants for Jay Harvard and Crimson and instead map our code to an actual database that can have one or more users in it, and any one of whom can be authenticated via this. So we'll go ahead and enhance our implementation of this notion of login so that we can support now multiple users and back it with an actual database. So how can we begin? Well, I'm going to go ahead and first create a table for my users. I'm going to call it just instinctively users, but I am asked this question by phpMyAdmin, number of fields. So here's where we have a design opportunity. If I want to represent the notion of a user, much like we supported for the first version of our login screen, what minimally do I need to store in this table? So username and password at least. So let's start there. Maybe we can do better, but let's at least start there. I'm going to hit 2 and hit enter. And I'm just going to get this nice little GUI screen here. So at the top left, I'm being asked for the field. So I'm going to call this user and this pass, because I think that's what I called the constants last time. I'm going to use lowercase by convention, just as my own habit. Again, pick your own habit, but stick with it. Be consistent. Avoid funky punctuation and characters. Avoid spaces. They are supported, but it just creates problems, frankly. It creates the potential for problems if you have spaces in weird places. So get into the habit of all lowercase or camel case or something contiguous, much like you would variable names. Now, here's the first learning opportunity. MySQL supports multiple data types. It's more data types than PHP. Most of them are fairly self-explanatory, but sometimes you do want to consult the documentation. For whatever reason, phpMyAdmin doesn't so much as alphabetize them, which makes it not so much fun to sift through. But the default, which is perhaps the most common, is called varchar. Any guesses as to what var means here? Variable. Oh, very good. So variable character length. So it turns out, if we scroll through this list, there is another variant of this same idea, just called char. down here. And here's where the first design opportunity arises. And frankly, this is where I think MySQL, or more generally relational databases, get interesting and fun, because you actually get to make a lot of interesting decisions up front that can influence the correctness of your code ultimately, the performance of your code ultimately. And once we introduce some other features of MySQL, we'll be able to also have some database level constraints, whereby if my code or my users try to insert data that shouldn't go there, for instance, 2 Harvard usernames, it's the database that can actually catch that error and prevent the second John Harvard from registering for my site. And even though I probably should be doing that in code too, at least I have another layer of defense. Or if I'm in a big company, the DBA, the database administrator, he or she can help protect our own data against mistakes on my end. So it's really nice now that you can have this additional control at a database level. It's frankly, I think, a lot of fun coming up with database schemas, and you can refine them over time as you realize imperfections in your own design. So a char, much like in many languages, char is fixed length. So if you know your usernames are only going to be 8 characters or fewer, you could actually specify a char field, and in a moment we can specify a length. You could say 8 characters. Now what's a downside here? One, can never have usernames that are 9 characters long. You can have 7 and 6. You can waste some of the space, but you can't exceed that. So why would you ever not just use a variable char, varchar, and just say varchar like 1,000 or 100 or something that's just crazy large that you'll never need more than that? But variable means you could have as many as that. So why go with varchar or char based on those definitions alone? Oh, okay, so overhead in managing the variable length, and what do you mean by that exactly? Good. Okay, so someone has to keep track now of this information, and in fact, there's the performance opportunity here. If you think about how you yourself might implement a database, well, if you've got a whole bunch of rows and they're all a fixed length, odds are you could take a row from this database and just like an array in memory, just put this field here, this one here, this one here, and if they're all fixed length fields, you can very quickly navigate that data because you can index randomly into any of those fields if you know in advance how long it is. But the problem with a varchar or variable length field is you have to keep track of that information, or you have to search for the end of the string before you can find the next one, something along those lines. So in general, choosing a char field with a fixed length is advantageous if you know you can bound the length of your strings, and you know, moreover, you're going to be searching on this field a lot, which probably for a username field you are. So even though for project 2, probably not a big deal which one you go with, but if you're implementing the next version of an e-commerce site or the next Facebook or something like that, where really you want to avoid spending cycles unnecessarily, you can expedite things like selects, searches, by knowing in advance how wide that field's going to be, because it just means the computer can then jump from here to here to here to here, fixed length, just 8 bytes at a time or whatever it is, and not have to do any thinking. So that would be one approach. And you proposed something too, I think. Okay, so you might be opening the door to security issues with longer variable length chars. In what sense, do you think? Okay, so the longer the field is, the more data you can store. So in theory, the more damage one could do by just cramming more potentially dangerous code into your database, whereas pretty hard to exploit a machine with just 8 bytes, probably doable, but at least you're increasing that risk potentially. So there too, certainly. You put yourself at more risk for storing some bad data. Yes, because well, not so random. Most usernames, at least on older systems, were bounded at 8 characters.
My question is, in Oracle, there was actually a storage advantage to characters as opposed to varchar, but I can't remember the length. Like, if you have a very short string, there's actually a storage.
Oh, okay. So I don't know the specifics for Oracle, but in general, using a fixed length string is advantageous simply because of the ease of indexing into it. And at some point, too, there are other text formats, and we won't really have occasion to use them just yet. Perhaps for final projects, there's this one, text, which might be your go-to element. The catch with text is that you have char and varchar. Varchars used to be limited to 255 characters, which is why in a lot of books you might see varchar 255 pretty commonly. And even I, just kind of for historical reasons, if I don't know in advance how long the string needs to be, but I'm pretty sure 255 is plenty, I just go go with 255 because, but you could go with most anything reasonable. Thankfully, that limit was raised years ago to 65,535, give or take. So that's less of a boundary condition then. If you need more than 64 kilobytes stored in a field, then you actually transition to something called text. The difference being a text segment, if you think about, again, this idea of storing something like a table, like this little picture of this of the Excel spreadsheet. If you think about storing this in RAM, sort of back to back to back, a text segment, because it's so large, would actually not be put among all of your rows and columns. It would be put like over there on disk, and just a pointer or a reference would be stored in the table for efficiency reasons. The upside of a text field, as you may discover, is that you can use what's called a full text search in MySQL, which means here's a big blob of text, do some fancy algorithms to expedite searches on this field, which can be useful as well, but it takes up space. But more on that to come, this idea of indexing. So for now, for username, I'm not sure what's best. I feel like I don't want to implement a 1970s, 1980s style website where my usernames have to be only 8 characters. So let's just kind of go ahead with a common default 255, but maybe 16 is fine, 32, whatever, so long as we pick some value. Password to 255. You're crazy paranoid if your password's 255 characters, but at least now I'm coming up with a reasonable bounds. Now, to push back here, I had probably better on my registration page for this website make sure to catch usernames and passwords that are longer than 255 characters so that I don't tell the user that you can choose this long username or this long password, but I'm only storing a subset of that. Certainly that would be bad from a mismatch of expectations, but who knows what problems could arise then if I start accepting passwords that are really longer or shorter than they should be. So bear that in mind too. It's not sufficient to make the decision once. You now better keep in mind this in your PHP or whatever code you're writing. All right, so what else is next here? So collation. This has to do with the encoding. We discussed encoding terribly briefly in the context of XML. The only thing I'll mention here is that in general you can leave it blank and the system's default collation type, encoding type will be assumed. Don't worry if you see Swedish all over the place. Turns out that MySQL was implemented by some nice Swedes, and so they went with their default encoding type, but thankfully English, at least for us here, is a subset. All the characters we might want to express in English work in that encoding set, so it's not a problem. So you can generally leave collation blank. Attributes here is inapplicable, but you can perhaps infer what types of fields might take advantage of this. So unsigned generally refers to what data type? Int, some kind of integral value. So in fact, just like you can in some languages, if you know you want an int, but you know you only want non-negative integers, you can free up half of your address space. You can go from 2 billion to 4 billion possible values by proactively saying, this field will never be negative. Don't waste one of my bits on a negative sign. Unsigned zero, unupdate current timestamp. The last one is relevant for certain timestamp fields. What's nice in MySQL and a lot of these database engines is you can have another field called last modified or something like that in your table, and anytime you update this row, that timestamp will be automatically updated for you. You don't have to think about doing it in code. It's just a nice feature for data accounting reasons and keeping track of last modification times. Now over here, we have a couple of other decisions to make. Once you have multiple fields, the UI, it's kind of dumb that you scroll left to right. Newer versions drop it down horizontally, but for now we'll just scroll. You can specify whether or not this field can be null or not. Must you have a value? Now what should we do here instinctively for a username field? So not null. Now this will help me at the database level avoid the difficult user who just leaves it blank for their username field. Again, I should be catching that in code, but here's another layer of defense, because who knows what might happen if I get some completely nonsensical empty username in my table. I don't even want to get to that point. How about password? Null or not null? Probably not null. So again, another layer of protection. But in some contexts, I might want to decide, yes, this can be null. Maybe if I'm storing not just username and password, but first name, last name, and middle name. Middle name, frankly, could probably leave that null for people. And frankly, depending on the culture, maybe one or both a first or last name should be null as well. You can specify default fields. Now, We could do something like a default password of 12345, not necessarily something you want to do at the database level, but this can be useful for other data types in particular. For instance, we have in our own database for the course a flag that says, are you enrolled for graduate credit, undergraduate credit, pass, fail, those kinds of things. So sometimes if we're going to assume the common case, very few people take the course non-credit, for instance. So if we have a field called non-credit, let's just have the default value be 0, and only for those students who enroll for non-credit will we actually flip that 0 to a 1. So you can come up with lots of compelling situations where it's just useful to assume a default. In this case, username and password, I don't feel comfortable really assuming a default, but we could. Over here, under extra, there's really only one option. Auto increments. Now we don't need this just yet, but we'll very quickly in the story today probably realize it feels like it'd be more efficient to pass around an int for every user and not a variable length string for lookups and for efficiency reasons. So if we start to assign every user in our database a unique ID, like a number, well, frankly, I'd much prefer the database figure out what the next registered user's ID should be, so I don't have to think about it, I don't have to manage it. And sure enough, one of the features of a relational database generally is to auto increment a number for you and then tell you what number was assigned to that most recent insertion into the database. For now, though, it's inapplicable. Finally, and we'll spend more time on this in the weeks to come, these various features, PHP-MyAdmin presents these with just these cute little icons, but for each field in a relational table, you can specify if that field is a primary key. And what's a primary key, for those familiar already? It's a unique identifier. A primary key is the field in a table that by definition can be used to uniquely identify every row. So in the context of this users table, password's probably not the primary key, because that would mean that every user must have a unique password, and there's really no reason to impose that constraint. It might also confuse people, and it's a leak of information to say, sorry, someone else already has your password. It's like, oh, well, I know someone's password now I need to find them. But with username, feels like that should probably be unique, especially since there's nothing else that can distinguish two users right now. So for this example, I'd probably click this radio button and say, yes, username is primary key. And you can have, by definition, only one primary key. But you can have unique indexes or indices. So MySQL lets you specify that this isn't a primary key, but it is in fact unique. In other words, conceptually, I'm not going to rely on this field to uniquely identify people in this table. But I do want to ensure that this field remains unique across all users. Can you think of a field we might want to add to this table where maybe it doesn't need to be the primary key but should still be unique?
Social security.
What's that? No, sorry, I just didn't hear.
No, that just came out.
Oh, okay. Retracted then. Yeah. Yeah, maybe email address, right? In theory, maybe you could contrive scenarios where you want to let the same email address get registered twice, but I feel like I'm going to make the design decision. I want everyone in my database to have a unique email address, and even though I don't want to use that as my unique identifier, because frankly, it's like a lot of characters. This feels like pretty long string comparisons to find people by this key. I'd much rather look up a 32-bit integer, which we don't have yet, but we'll get there. Feels like I at least want to make sure that even the email address here is unique. Maybe you can come up with other fields as well, but that's perhaps a pretty good one. Social security number. Frankly, for privacy reasons, for regulatory reasons, I don't want to pass around their social security number all over the place, but in theory, it should uniquely identify everyone. I'm just not going to rely on it as my conceptual and technical primary key.
Is this terminology specific to MySQL where, it seems like every primary key is a unique key, but not every unique key is a primary key?
That is correct, and this is a SQL thing, not a MySQL thing. So there's this one here, lightning bolt. So the lightning bolt is PHP-MyAdmin thing. So this one here, index. So this is where, frankly, it starts to get a little fun, and you have to start making informed decisions, especially when your data set gets large. This field here, you can specify, I want this field to be indexed by the database. Now, what does this mean? If you know in advance that you're very commonly going to be searching for fields in this database, using this field, as seems pretty reasonable for a username, you might want to specify index this field so that I can find it quickly. Now, what does this mean? If you do not index a field in MySQL and you do a search on that field saying, give me all of the rows where foo equals bar, and you have not indexed the field called foo, essentially MySQL or whatever database you're using will have to search the entire table, top to bottom. By contrast, if you in advance have the foresight to say, you know what, index this. It's going to cost you some space and some startup time because it's going to have to build a fancy tree structure in memory, a hash table essentially, but henceforth selects are going to be super fast, most likely. But the problem, or the trade-off here is if your database is now getting to be like 1,000 users or 1,000,000 users, you're going to start using more and more disk space. Can you afford to do that? Does that make sense? Can you afford to spend the additional cycles to maintain that index? If you're inserting a lot into this table, it's possible that MySQL could slow down a bit because it has to keep massaging this tree and keeping it updated, so you might pay a performance penalty there. Now, for most applications, you don't have to worry too much about that level of thought unless your load is really getting high. But it's fascinating when this actually applies in the real world. I think last week we looked at the Harvard events site that we were playing around with, and the predecessor of that version, which was made several years ago, it was very slow sometimes doing certain keyword searches. And I finally put aside some time to look through the various tables we were using and such, and we were missing some very important indices on certain fields. So accidentally, we were constantly doing an exhaustive search of these tables. And when you store data for 3 years worth of events, we had tens of thousands of events in there. So these searches just kept getting longer and longer and longer over the months. And honestly, clicking a button or running an alter command at the command prompt fixed all of those performance problems because it said, finally, make a nice data structure with which to find data in this field. So you might be inclined, when new to this world, well, heck, just index. Just make everything an index. But again, there's a trade-off there, particularly with space. And that's not a good thing to spend space if you're just never going to use that field. So here, realize that these are exclusive. If you're going to make something a primary key, it's indexed by definition of primary key. If you make something a unique key, it is indexed by nature of uniqueness. If you don't want to enforce uniqueness, or aka primariness, if you will, you can minimally index it, and that does not impose the same uniqueness constraint. This -- just means nothing. This last one, the T, is just applicable in the context of text fields. This is a flag you can check if you have a full text field, and if you have a big body of data. In the context of the event site, we store, I think, the descriptions in a text field, or we used to, and that's so that we could check this box and say, full text index search this, because one of the nice features MySQL provides is it can do Boolean searches for you. It can do Google-like searches, where you can pass in a string with plus foo minus bar, and that will say, find me all fields that say foo, but do not say bar. And you can do this because if you tell the database in advance, index this in your special way, you can create what's called a full text index. And that's what that last field does. And comments is just for your own edification. So a lot of information all at once, but these are the kinds of ideas that you'll get to consider for yourself with project 2, 3, and probably your final project as well. Any question? Yeah?
What's PHP about this anyway?
The fact that the code underneath the hood is written in PHP to create this GUI. But for our purposes, purely a coincidence. Could have been written in most anything.
You mentioned the text data type, and then the last thing you could check full text.
Mm-hmm.
What are the difference between those? Because I thought the text database was also, data type was also, had some searching functionality.
So you can search on any field, even without having an index or full text index defined. The question reduces to how much time are you willing to spend. If you actually proactively declare a field as an index or a full text index, your subsequent searches will be a lot faster, but you don't have to index fields in order for them to be searchable. Case in point, our previous version of the event site was working, but it was horrible with certain queries because we had forgotten to include certain indices. Yeah?
Can indices be made up more than one field?
Yes, in fact. And this, yes, in this interface here, we can't see this, so let me go ahead and click Save. I saw another question go up, so let me go ahead and click Save. Then we'll see how we can do that and why we might want to do this. So let me make one last comment before I hit Save. Just as in the file system world, you have things like HFS Plus and NTFS and FAT32 and all these different implementations of file systems. There are also different implementations of database engines that themselves offer different features. The default, typically in MySQL, is this thing called MyISAM. It tends to be very high performing. It does not offer something called transactions, which is something we'll actually discuss next week. So there are some fairly interesting scenarios that arise where you don't want to use this engine if you want to ensure that multiple queries all happen at the same time or not at all. Atomic queries, is the topic that'll come up. But just to tease you with some others, InnoDB will often offer something called transaction support, which again, next week. Memory, aka heap tables, are tables that live purely in RAM. So if you know in advance you want to do lots of searching and sorting, but you don't care if the data is lost when the machine reboots or whatnot, you can proactively say, keep this whole thing in RAM. Which is a nice feature. Federated is actually kind of cool, whereby for larger deployments, you can partition your data, and we'll talk about this toward the tail end of the semester in scalability. You can say all of my usernames starting with A go on this server. All of my B usernames go over here, C over here, and so forth. It's a common approach to database design, just break up your large data set into different clusters. Federated is a means by which you can create the illusion in code of having just one big table with the A's and the B's and the C's, but underneath the hood, all the A's end up going there, all the B's here, and it's a nice illusion so that you don't have to change your code or mental model, but for performance reasons, you can divvy things up nicely. And then there's some other things. Archive is particularly well compressed. CSV you can do just because it's similar in spirit. And mostly, though, you will use InnoDB and or MyISAM. The others tend to be called up for only in sort of higher load or more interesting or less typical, less common cases. So let me go ahead and click Save. And I will see this. And now as a word on the syntax, again, it's not all that hard to remember. I just have gotten lazy over time. This is what I would type at a command line or an actual code if I wanted to create this using the pure SQL syntax. Again, not hard. Create table, the name of the table, and notice I have dot notation here. Let me zoom in on the right part. So mail and lecture is the name of the database. Dot users is the name of the table. It's perhaps hard to see at this resolution, but surrounding each of those words are backticks, the character near the tilde on your keyboard. This is MySQL specific. There are certain keywords that are reserved. Group, as we'll see, is a reserved keyword, but group, pretty common field name. I might want to have a group of users. But if you use backticks around any of your special keywords, table names, field names, you can use most any words that you want, even if they're reserved. So they are backticks. They're not single quotes in this case. What comes next? Open parenthesis, close parenthesis, inside of which is line by line in this case, so that's just aesthetic. The name of the field, the type of the field, the length of the field, and then extra parameterization like not null. And then finally, the engine stuff. So again, good exercise to start retaining this stuff, but because you create tables far less often than you actually select them, we'll be writing a lot of selects and updates and inserts and deletes and less of the create table syntax, which tends to be a one-time upfront cost. All right, so now notice that I didn't actually check any of those buttons that we talked about because I'm being yelled at here, no index defined. So this is actually here too. It's frankly a useful tool because you get this visual feedback as to what's good and what's bad about your design, at least in part. Now, if I want to go back now and impose some indices, I can just check the boxes in phpMyAdmin, or I could use the alter syntax in SQL. So let's go ahead and do that and see what's executed. On the right-hand side, I realize now, oh, wait a minute, this really should be a primary key. So this key icon is the one that does that. So I'm going to click that. It's going to say, do you really want to alter table users add primary key? So that is literally the syntax for the SQL command. I'm going to say OK. And the database is pretty fast, right? You can see Google style, this took 0.0108 seconds, not all that fast, and this isn't even that fast a server. Now I'm not being yelled at anymore. In fact, I'm being reminded that I do have some indexes, one called primary, and in fact, it's right there being pointed out to me. So it's not quite applicable here, but you can come up with scenarios where you would actually like to have joint keys, two fields that together must be unique. If only because this is the most recent example of this I used. In that event site, we have the notion of multiple calendars. So each calendar has a whole bunch of events. So let me go to events.college.harvard.edu. And per the drop-down that I think we glanced at last time, there's like 200 plus calendars in here right now. Now, by definition of a calendar, each calendar has multiple events, and each of those events on a given calendar tends to have a unique ID, 1, 2, 3, 4, 5, 6. Now, the IDs for an event must be unique on a calendar, but they don't have to be globally unique because all of these are independent calendars run by different people. Wouldn't make sense if the whole campus had to coordinate unique IDs for events. So here, conceptually, I need to have a joint unique constraint that says I can never have a calendar and an event be identical in multiple rows. So by having a joint unique key, but using calendar ID or name, whatever, and the event ID, I can ensure in this way that every calendar's event IDs need to be the same, but they don't need to be globally the same. Because if I have two events in the database with ID 1, 2, 3, but they're on different calendars, those two calendars would have two different IDs, and so I would not violate this constraint that's joint on the calendar ID plus the event ID. And you can come up with other scenarios. Frankly, this is the one that I just happened to be playing with last week, where it was useful to impose that constraint, so I didn't run into any bugs down the road. Any questions on keys, or AKA indexes? All right, so let's actually use this now. I've got a field for user. I've got a field for pass. Let me go ahead and insert some data. Well, I can do this with the syntax. First, I'm going to use the GUI. Then we'll do it sort of old school style. I click the Insert tab. Anything you might do interacting in PHP-MyAdmin is done via this tab setup up here. I clicked Insert. Notice here that I have the user field, the pass field. Turns out MySQL supports some functions. We'll look at some of these next week. But for now, we're just going to use some raw values. I'm going to insert jharvard and password crimson. I could insert multiple rows at a time if I want, but for now I'm just going to do one. What's important for now, though, is, again, not the PHP-MyAdmin interface, but what was executed. So this is just pretty printed on multiple lines. Could be just one long line. But here's the syntax for insertions. Pretty straightforward. Insert into database.table. Though, frankly, if you're already connected to the database, you don't need to constantly specify name of database dot. It's just doing this to be pedantic here. In code, it suffices to use just the name of the table, we'll see. Parenthesis, close parenthesis. A comma-separated list of the values that you want to insert into, user, comma, pass. And then here, values, open paren, close paren, and then a comma-separated list of the values you want to insert for those fields. So let's do this manually this time. So again, to ignore the pretty printing that's going on, this time I'm going to click the SQL tab, which allows me to actually type in manual commands. And I'm going to do this. Let's go zoom in and type insert into, it's called users. And then what do I want to insert? The user field followed by the pass field. What values do I want to insert? Well, let's do Malin, comma, 1, 2, 3, 4, 5. And then semicolon, although the semicolon is not strictly necessary if you have just one statement. Go. Inserted rows 1. Query took very few seconds. And this is what I just typed again. Again, it's formatted differently, but that's it. So you insert into table name, comma-separated list in parens of the fields, comma-separated list of the values, prefixed with the keyword values. So now let's see what's in there. Let's browse. So if I just click the Browse tab, notice that here is my little row. It's printed with nice little HTML, but it allows me to visualize what essentially is in my Excel spreadsheet or whatever. Well, what's really being executed? Let me do it the old-fashioned way, because this is the way we're going to need to do it in code anyway. Let's use the select syntax. Select. I want to select everything, so I'm going to say star from the table called users. And that's it. This says get me back all of the rows from my database from my table in the order in which they were inserted, but we can change that later. Go. In fact, I see the exact same thing that I saw a moment ago, because by default, when you click the Browse tab, that is the query that it executes. Well, I don't care about passwords. I just want to select users. So let me go ahead and click the SQL tab again, and now just specify select user from users. Now I'm going to hit Go, and sure enough, what I get back this time is another temporary table. This time it just has the field user in it. Again, the GUI now is useful because, frankly, with most projects I tend to do these days where you need an administrative interface, if I'm going to be the administrator, I don't bother actually implementing an administrator interface if I understand SQL and I understand that I already have this GUI tool. So frankly, in the interest of expediting development of projects where you yourselves are going to be the maintainer of the database anyway, and you probably don't want to spend another week, another month implementing a whole administrative interface to be used by you, here's a wonderfully useful administrative interface. You can do a lot of damage because you have now unfettered control of all your data. But frankly, even for the courses database where we keep track of students and grades and whatnot, well, frankly, if someone drops the course, you know what we do? We don't have an interface with the little drop-down menus and all that for updating it. We open up PHP-MyAdmin, we click the little X, and execute the delete command, and it does it for us. So frankly, I can't tell you how much time using this particular tool or anything like it saves you, because you don't have to bother implementing certain features. Now, with that said, that's totally cutting some corners. I probably wouldn't hand this to a lot of less technical people I know, because it's a little too easy to click the drop command up at top right here, for instance. But here too, as was suggested earlier, with an actual database engine comes the ability to have access controls. So frankly, I could create a not so technical friend as a username, and then I could revoke certain privileges. Like I could prevent him or her from dropping, from emptying, from deleting. I could restrict the commands that he or she can execute to just selects, for instance, or just inserts. But again, that's just a real-world tip, not sort of a don't submit PHP myadmin, for instance, as your project too. So let's actually use this now. We now have a database table with just one user. So we haven't made huge progress over the first version of our login mechanism. But let's go ahead now and try to implement precisely this feature again, but in a more compelling way, this authentication. So I'm going to go over to the courses server here. I'm going to go ahead and remind us that we had, let's see, like today, we had lecture 4 source. So recall that we had this, home.php, which recall showed yes or no, you are logged in. So let me open this now up in a browser. Let's go over here, home.php. Recall that this was the little mock-up that we had this time, but this time I've linked to newer versions of this that are going to be SQL-based, not PHP constant based. If I click version 5, I want to be able to type in my username, my password, click login, have my PHP code receive the data in the get or the post superglobal. I want to then use that data to execute one or more SQL commands to check, is this user and this password actually consistent with the row in my table? And if so, I want to log the user in. If not, I want to yell at them and say that was not valid. So I'm going to have to fill in a couple of blanks now. So let me go ahead and open login5.php. Structurally, it's almost identical to the code we used previously. I call session start at the top, but now I have to have some PHP myadmin specific stuff here. So let me go ahead actually. Last time I played with this code was clearly a year ago, but let me change this to Malin lecture and 1, 2, 3, 4, 5. So what commands are relevant here? Let me actually change this to be consistent with the database I made tonight. So let's take a look. So here's a new function, MySQL Connect. With the MySQL Connect function, you give it 3 arguments, the name of the server to which you want to connect, the username to use, and the password to use. So what am I connecting to? In this context, the database I'm playing with today happens to run on the same server, cs75.net, so I'm connecting to the host name called localhost, aka 127.0.0.1. The username I created in advance tonight was called Malin Lecture. The password I gave to this account was 12345, and it's wrapping because my font is a little big, but notice that I'm just checking the return value of this function and checking if it equals false, something went wrong. Odds are the credentials are wrong, the database is offline, something bad happened, and so I'm just going to call die. Not generally good practice for production code because the user is going to see a line of text at the top of the page that just says could not connect to database. Surely we can come up with something more user-friendly, but for demonstration purposes, I just wanted a quick and dirty sanity check. So die gets the job done. It's a synonym for exit. All right. If, though, that was successful, I want to proceed. And I want to select the specific database. So even though you might think of a database and a database server as being synonymous, they're actually different ideas. MySQL is a database server. It's a piece of software that runs on a computer that can run all sorts of other servers, like mail and web and others. But MySQL is a database server inside of which are one or more databases that different users own or control. The one I created for tonight is called Malin Lecture, so I want to select that database specifically, because by the end of the semester there's going to be like 100 more databases owned by students in the course on the server as well, so I need to distinguish between the two. If this user and this password don't have access to this database, this line is going to yell at me, because I can't select it if I don't have the privileges, but hopefully we will proceed to the next line. So now a sanity check from last week. If user and pass are set in the superglobal called post, what's the implication? The user submitted the form, right? That was our implicit check that they got here because they submitted the form and not because they just pulled up the generic URL. So now here comes MySQL. So here is where you can now commingle a third language, or fourth if we count CSS, into our PHP code or into our HTML code. We have some SQL. So even though a moment ago I was executing my SQL statements in a little text area, that was just a UI mechanism. What's interesting tonight is the SQL syntax itself, the SQL statements, and those are things that start with keywords like select or insert or drop or create. Here is a select statement. So I'm using, this is a common trick, at least with these fairly simple functions. sprintf is a string creating function, much like printf, which prints to the screen. sprintf is useful for a reason we'll see in a moment. But I'm calling sprintf, and I'm creating on the fly a string that says this. Select star from users. That's where I stopped last time, but I can be more specific. Select statements support conditionals, just like XPath supports predicates, where I can say where something is the case. Where user, the field called user, equals, so it's not equals equals, it's a single equal sign, equals quote unquote something. Now I'm trying to preach some best practices here. So %s is just like the printf world, it's a placeholder for a string. That's what the s implies. Now, even if you're not familiar with SQL or PHP all that much just yet, why might I be using this placeholder and using sprintf at all, do you think? Yeah?
Because you're going to insert something in there.
So I want to insert something in there, but I know already I want to insert the user field, but here is just my first defensive maneuver against these things we're going to call before long SQL injection attacks. If a user tries logging into my site and doesn't type in jharvard, but types in something like semicolon delete from foo, I don't want to accidentally confuse or assume that what they typed in is actually a username when it could be a SQL command. Because what if they do type in a semicolon and then a scary statement like drop or delete, and I just naively concatenate their string with mine that I started creating here, the effect of which is to select some data, semicolon, delete some data, the latter of which I did not intend. So there are other ways to do this, but a simple way to do this early on, at least with the functions we're introducing tonight, is use sprintf, which allows you to use these placeholders, like %s. I surround it with single quotes, which is necessary for a string in SQL, if you want to compare against an actual string. But then notice, close double quote, comma. So the comma demarks the second argument to the sprintf function, and that's what value should get inserted into that placeholder called %s. Now, it's a ridiculous name, but MySQL, rather PHP has a function called MySQL real escape string, whose purpose in life is to ward off SQL injection attacks and some other things, but SQL injection attacks. How does it do that? If there's a semicolon in there, backslash goes in front of it. If there's a single quote in there, backslash goes in front of it. So anything that's potentially dangerous is escaped automatically by this function. I could do this myself in any number of other ways, but a nice workflow, at least initially, with PHP's MySQL functions is use sprintf to dynamically construct a string, which is going to cost you a few cycles. It's not the best use of memory, but the upsides in that you're protecting yourself against a very common threat is pretty compelling. And so in the end, I have a string that says select star from users, where user equals quote unquote jharvard, or whatever the user typed in. Now, frankly, at that point, if the user types in something crazy with semicolons and quotes, who cares? I've escaped it. They're going to get back 0 results because I probably don't have a username called semicolon ... whatever. So they're only disappointing themselves, not me. So now I have a string in memory. I've stored it in a variable called SQL, just arbitrarily. Now I'm going to execute the query. An SQL query, just like an XPath query, returns what's generally called a result set. This is a collection of 0 or more results, or an XPath, 0 or more elements, or nodes more generally. In the context of SQL, 0 or more rows from the table. That's what you get back in your result set. So I'm going to call the variable for the return value result. I'm calling MySQL query and passing in that string of SQL. So here is the programmatic way, or the programmatic analog of the text area I typed into in PHPMyAdmin's interface. Now I'm sort of doing this the real way, with the programmer's way. So sanity check. If the result equals false, something happened. Odds are it's a syntax error. During development, I would say the best approach when you're running into weird errors where false is being returned, when really you should be getting back 0 or more results. And to be clear, getting back 0 rows is not an error. That's just a fact of life. Getting back false, aka error, generally means a syntax error. You got a single quote in the wrong place, you called a field that doesn't exist, something like that. False does not mean 0 results. False means human error on your part. So in this case, what can I do to diagnose that? Well, this actually isn't that helpful. I'm generically dying and saying could not query database. I can actually do something like this if I want to be more helpful to myself. Not for users. They probably shouldn't see this. But I can concatenate in the return value of a function called MySQL error. And this is a string that's reasonably user-friendly, developer-friendly, that tells you what the problem is. Though, frankly, a very common approach during development, I would suggest, is if you know you're doing something funky and that's causing an error. I very commonly do this myself. If I know no one's going to see this, because I'm doing it on some test site, I'll just die with my query there. My browser will then show me the query I just constructed, and then what would you suggest I do with it? Copy and paste it, honestly, into PHP-MyAdmin's interface, where you have maybe a more familiar home, a more user-friendly environment to play with that query, change it by adding and deleting characters, get it right, then go back to your code. Many ways you can approach this, but if you're looking for sort of real-world tricks, hugely helpful, frankly, being able to see what you're generating, paste it into a UI you can then play with, then go back and realize, oh, I left out the single quote or something silly like that. It's hard to see otherwise, especially when it's new. So at this point in the story, let's suppose there was no error, so I don't get back false, so I proceed further. So now I can do this in any number of ways. I have selected all of the rows where user equals quote-unquote something, maybe J Harvard. Now, because of my uniqueness constraint, or my primary key, I should get back how many rows potentially? What are the scenarios? 1 or 0. 0 or 1, right? If J Harvard exists, I'll get back 1. If he doesn't exist, I'll get back 0. If I get a false, then again, it's my fault. I did something wrong, not the user. So I can check for this in a few ways, one of which is this. I can call a function called MySQL_numRows, which, just like the count function for arrays, tells me how many rows are in this result set. And if it equals 1, does that mean the user is authenticated? Okay, not yet, because we now need to check the password. So let's check the password. So if I get back 1 row, that means I found J Harvard. Now let's check this guy's password and see if it's the real J Harvard. So let me scroll down. And now here's how you get at the actual row. So because it's a result set, it's essentially a collection. It's like an array, but it's not array syntax of rows. You need to get that first row. So to do that, there's a few functions you can use. Let me scroll down so I can point at it a little more effectively. But in this line here, I'm calling this MySQL fetch assoc, fetch associative array. What's nice here is with this function, I will get back an associative array, a hash table, a map, whatever, whose keys are the names of the fields, and the values are the values from this particular row, the first row in the result set. This is nice because it's just programmatically very convenient, because now I can use some nice PHP syntax and I can say if the pass field in this row equals what the user typed in, now I know this is the real John Harvard, or someone who knows his password, and so I can follow all those steps from a week or two ago where I authenticated the user. The rest of this is copy-paste from our past examples. If, though, what the user typed is not equal to this row, I'd better reject, and sure enough, if I scroll down, I then show the page here again, the form again. I've not logged him in by tucking anything away in the session. So that's one way. I select everyone named J Harvard, which is hopefully 1. I then check that guy's password against what the user typed in. Would you propose a refinement to this that might involve a little less work?
I don't know about less work, but it seems like you wouldn't want to store the password just in the text field.
Okay, so I might not want to store the in what text field?
Or, sorry, in the var char. It seems like you wouldn't want to just store the password in the database.
Okay. So we might not want to store the user's password in this temporary variable called row, this associative array. So we could try to mitigate that. Other thoughts?
A little aside.
Okay.
In order to use this, you go through this page twice. Once to display it with blank fields and once to check the password.
Correct.
So you're connecting and opening the database twice.
In this case, unnecessarily.
Okay, is that... Okay.
In this case, it feels stupid. So I did it this way just for... actually, stupidity. There's really no reason for it to be at the top of the file. Better would be, this is actually a compelling point. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. Frankly, these 8 lines probably should go here, because otherwise I am indeed connecting to the database unnecessarily. So yeah, I will absolutely concur with that. So newbie mistake on my part. Okay, so now can we do this? So there's one potential concern on the table. We're storing a password in a variable. Feels like it's unnecessary, if only because now we've got some bits in memory that if the right kind of adversary got there could maybe find this password in memory. But also, I feel like I have a query language, and I've not seen the syntax yet, but clearly I can have where clauses in my SQL statement, and clearly the database can do a comparison. Heck, let's have the database do both comparisons for username and password and not reinvent the wheel that MySQL has already invented for us. So I'll save this as the updated example. We'll go to press with the corrected version there, or the optimized version. Let me go ahead and open login6.php. So here too, newbie mistake. We'll just fix this real fast. 8. Never saw it. Okay. So now I'm connecting to the database only when I need to. But now notice what I'm going to do, sled optimization. Now you can do this in different ways too. This time I'm sort of oddly selecting 1 from my table where user equals this and pass equals that. So I'm clearly now using a Boolean where clause, and that is possible using and, capitalized by convention, doesn't need to be, but I'm anding together 2 clauses, so I'm now pushing the work onto the database, and I'm only getting back a row if we find a row whose user is something and password is something. Now the 1 is kind of arbitrary, but it's a slight optimization. What happens anytime you select rows from a database, you get back a result set, but really that's a temporary table that's been constructed using the fields you asked for. If you select star, you pretty much get a copy of the table you asked for. If you select username, you get a temporary table with 1 column in which are usernames. I don't need to get back any of that data. I just need a yes/no answer. Is this username and password in some row in the field? So frankly, the least amount of information I can ask for while still getting back a temporary table that's useful is I can just select a 1 row, 1 column table, temporary table, which contains only the value 1. Now, why 1? Frankly, it could be anything. 2, 3. I just wanted to select the fewest number of bits possible so that I could still call MySQL num rows. Because now, logically, if I found the user and I found the pass, I'm going to get back a temporary table with 1 row, 1 column. I can still use this trick. And now I don't have to bother looking at the username or the password because I pushed this onto the database. But slight problem. I made user a primary key recall. What other keys did I find? Did I define? If you click the Structure tab in phpMyAdmin, you can see what you did. Do I have any other indexes? And yet, notice what I'm doing. I am asking MySQL to look up data based on this, and I'm asking it to look up data based on this. Feels like I probably should have a key on the password field as well. And sure enough, right now, because I'm doing a comparison on the password field, I'm essentially doing an exhaustive search, or partial exhaustive search based on the username matches. Feels kind of stupid. So I can fix this or improve this in one of 2 ways. I probably don't want to make it a uniqueness constraint. It can't be primary, because by definition of primary, you can have 1 primary key. Uniqueness would mean 2 people can't have the same passwords, and again, that feels a little arbitrary and unnecessary. So I do want to index it. So I want to alter this table and add, using this syntax, and again, this is one of those one-time things, an index on the pass field. But frankly, a slightly better optimization here is now we do have a candidate for a joint index, because if I know in advance I'm always going to be selecting on this field and this field, what I've done is pretty good, an index on both. But in theory, I can do slightly better performance-wise if I check both of these rows and then check this index field here. So notice this icon's outside the whole table. That was, did that work? Yes, that did work. Didn't give me any feedback for some reason. Notice now at the bottom of my little cheat sheet here, I have 3 indices. The last one is arbitrarily called user. MySQL just comes up with arbitrary names for them. Doesn't really matter what they're called. And notice, though, as this suggests, now I have a joint index on those 2 fields, which performance-wise will probably be marginally better than just using the 2 separate indices alone. Which is better? It depends. I probably don't need the pass index now as well. Feels a little wasteful, so I could delete that index. But here, too, again, a fun design opportunity. Now, for 1 user, 2 users, 100 users, 1,000 users, we're probably not going to notice the difference. 10,000 users, you probably will notice, even if you play with phpMyAdmin, that the number of seconds or milliseconds required in the queries is going to go significantly down now that I'm actually indexing my data.
I mean, at least in this situation, couldn't you have put both of them into the primary key?
So, good question. Couldn't I just put them both into the primary key? Yes, you could, but I would say that would violate just a conceptual constraint, which is that a unique key a primary key is generally meant to be the least amount of information necessary to uniquely identify rows. So while your suggestion would work, and it would actually use a little less space, it would kind of violate the spirit of a primary key and probably shouldn't be used. And in fact, once we introduce next week a numeric ID for each user, we probably really wouldn't want to get to that, because then we're defeating the whole point of using as little space as possible. Yeah?
Will that compound key be used with the query as you have it, where you say where user
By adding them together, yes. The database engine should realize I'm searching on these two fields jointly, and so it should leverage that index as a result.
Along those same lines, can you tell MySQL which index you want to use if you know there are multiple?
That's a good question. Can you tell MySQL which index to use? I don't know if it supports that syntax. The database is supposed to be smart enough to figure that out, but I will check the documentation because I've not actually tried that myself. So a lot of fun stuff to come. I'll stick around with questions. We have Alex's section across the way in just a little bit. We will see you next week.